Hello, and welcome to another Make a Code Monday. My name is Max. I'm a programmer from the Innisfil Idea Lab and Library, and today I have kind of an interesting project to show you. So using Make Code Arcade, I would like to show you how to do this. So we are a little duck flying around. We hit this power-up orb, and then suddenly we have this other sprite which follows us in a circle. You may have seen things like this in kind of space shooter games like Gradius or something like that, where you have this orbiting character that when you fire your laser beam, they also fire their laser beam. So, kind of like a fun power-up in a space shooter type game. And so yes, that's the code I would like to make with you today. So if you head over to arcade.makecode.com, you're just going to go ahead and start a new project. The new project, of course, needs a very fancy name. I'm just going to call this one Math. Lots of math will be involved today. So we create that project. So, as I demonstrated, this is a game with a flying sprite, a power-up that you select, and then all of a sudden there's an orbiting character around you, which you can use in any number of different types of games. So first things first, let's set the scene here. Just a very basic background color. So scene, set background color to, well, this time let's pick dusty purple. And then we want a character to move around the screen. So under the sprites drawer, set my sprite to sprite of kind player. In this case, we're going to rename this variable. I picked a duck earlier, so might as well call this duck. Say OK. So now our character has a name, which is great. Click on this gray square, and we'll give that character an image. Surprise, surprise, the duck, for this game anyway. And we hit done. So we have a duck of kind player. That's perfectly reasonable. To move our character around, we're going to move my sprite with buttons from the controller drawer. Place that underneath your character. Of course, we need to change the name from my sprite to duck. And so move duck with buttons, and the default speed is probably fine. 100 pixels per second, X and Y. Just realizing our duck kind of has a border that's the same dusty purple, so we'll go with less dusty purple. We're going to do a few things, and we can set up kind of the boilerplate here in the on start block. We're going to adjust an object's angle, and I think it's easiest to keep track of that just with a standard variable. So under variables, we're going to make a variable, and big surprise, we're going to call that angle. By default, at the beginning of the game, we're just going to set that to 0. We just want to put that variable somewhere and give it some kind of value. As you saw in the game, we had a power-up that we run into, and then we use that to gain the ultimate orb-busting power. And so let's just make a power-up under sprites, set my sprite to sprite of blank of kind player. Perfect. Once again, change that name to something much more recognizable and useful for us. We're going to rename that variable to power orb. And the power orb, well, lucky us, lucky us. In the gallery, there is a delightful and thrilling orb shape, which we can use as our kind of power-up in this game. So we hit done there. Based on the way we're going to interact with this orb, I think it's best if we actually give this a new kind. So in Make Code Arcade, you might have seen that all objects have a variable name, an image, or sorry, all sprites have a variable name, an image, and a kind. And so we're going to set this kind to something brand new, and we're going to call this a power up. There may be all kinds of different power-ups in our game. This one is a power orb, so we're going to give this the kind of power up. When we make our overlap, it'll be very important that the orb has its own kind, because we're going to have the donut also be its own kind. And so just to separate the interaction between these types of objects, the orb has its own kind of power up. We can place that randomly on the screen. This is just for demonstration. Probably in your game, you would want to make your power up appear at a certain point for a certain reason. For just right now, I'm going to use the set mySpritePosition to set the position of the power orb, and we're just going to place that someplace on the screen using the little crosshair here. I clicked on the 0, and we can select a position on the screen for that to appear, and that's good enough for us. Anyway, this is just the boilerplate. This is the foundation for how the interaction in the game will later on work, but of course the fun part hasn't really yet started yet. So let's stop with the boilerplate and make our rotating donut. And so for now, I'm going to put the donut also in the onStart block using the sprites drawer, set mySprite to sprite blank of kind player. Once again, here, well, I know what I'm planning. I know I want to call this and for this to be a donut. So we can say OK there. And as you can already see, imagine if these were all called like mySprite, mySprite1, mySprite2, that'd be very confusing. So that's why I think it's always very important to rename your variables. So my donut is going to be a donut. This donut here is 16 by 16 pixels. This other donut is huge. It's like 32 by 32. We will stick with a regular donut for this one. So we click that donut and press done. And as I mentioned earlier, I want this to be a particular kind of object. It's going to be food. So the donut, when you generate it, it just kind of hangs out in the center there. Doesn't do what we intend it to do, and that's where we get to have some fun. I want this donut to move around the player at a particular speed, and to kind of activate that, one way to do it is using the game block on game update every 500 milliseconds. So this C-shaped block, of course, means we can put things in there. I'm going to change this to be very brief, every 10 milliseconds. And what we want to do is kind of fun. I mean, you'll tell me how fun you think it may or may not be. We want to set the position of our donut, and so set mySpriteX to 0. As always, this is a very versatile block, but of course lots of changes to be made. We want this to be our donut number 1, and X is fine for our purposes right now. And here's where it all begins. We have some math to do. So the basic set donut X to 0 block does what it says. It puts the donut X position to 0, which is the far left of the screen. To get things moving in a circle, we're going to do a fun little math equation. We need a little multiplication. So from our math drawer, we want this 0 multiplied by 0. 0 multiplied by 0 is 0, so the donut will be in the exact same position. But here's where things get kind of fun. We're going to use the math sine function to do some very interesting movement. And so almost threw myself for a loop there. The square root block is where the sine function is hiding. So under the math drawer, square root of 0, underneath that drop down is the sine block, or the sine option. I kind of think that should be separate. I don't really feel good about hiding sine, cosine, and these other things underneath square root, but anyway, so sine, and then in here will be a given angle. I'm not the best at trigonometry, but my understanding is that the sine value is the length of the vertical side of a right triangle divided by the length of the longest side of that triangle, the hypotenuse. So by dividing those two numbers together, you get a ratio between those two sides, and you can use that to, in our case, plot points around a circle. If I didn't get that right, please let me know in the comments, because as I've already mentioned, trigonometry and me are only acquaintances. Anyway, the way we're going to use it practically here is we are going to put into the sine function a variable, and that variable is our angle. By putting the angle in there, we will multiply what will become the radius of our circle, which is currently set to 0, multiply that radius by the sine of a given angle. And so just to get started, let's just put in a radius. The radius you can also store in a variable. I know I'm not going to change my radius over the course of this project, so I'm going to put in the number 30. So the radius, a radius of course is the distance between the center point of a circle to the outer edge of a circle. So that length multiplied by the sine of an angle will essentially draw us a circle as we keep on updating the angle. If we keep on updating the angle from 0 to 360 degrees, this function will set the x position of our donut along a particular path. And this, paired with a very similar block of code using cosine, will draw a circle. And so to see this in action, let's duplicate this. And we're going to change the y by the cosine of an angle. And so you see almost nothing has happened there in the code editor. Really, actually, what's happened here is we're plotting a particular point at angle 0. So angle 0 is what the value of that already is at the beginning of our code. And so at angle 0 with a radius of 30, sine and cosine, has plotted our donut at a particular point. And so, if I just change that angle just to say 45, our donut will be in a different position along the path of that circle. And so the trick for us right now is to just update the angle so that these two functions, the sine and cosine functions, continue to plot the position of our donut at a certain radius around our circle. And so this part is easy. We're just going to change a variable value. So under the variables drawer, change my sprite by 1. Well, of course, that's going to be angle. And we're going to change it by a very small amount, 0.06. And then that'll change how fast our donut rotates. And so our donut is moving around there. And that's pretty good. Of course, we can change all sorts of different values, and you'll get a different result. If we do this every 1 millisecond, the donut should move very quickly, or at least quicker. If we keep that to our 10 milliseconds, but change the angle rate of increase to 2 degrees every 10 milliseconds, the donut goes kind of blindingly fast, a little bit of a strobe effect there. And so that's why we stuck to our 0.06. We're incrementing the value of the angle, and so this keeps on going up from 0 to 360, changing 0.06 degrees as we go, and thus plotting the circle. That's all well and good, but we see that the donut is orbiting around the origin of the screen, which is 0, 0. In order to get it move around our duck, we're just going to do a funny little trick. I mean, you tell me if it's funny. We're going to just pop these two bubbles out of here, and we're going to put in there some more math. We're just going to add the initial position. Since we know the donut is orbiting around the origin point, that means we just got to do a little bit of literally some additional math to find out how to make it move around our player. And so we're going to add from that origin point, the coordinates of our player. And so under the sprites drawer, we want my sprite x, and then we can change that to duck. Duplicate this. Put that into the cosine version and the duck's y. And so now we finally have an orbiting projectile. Ooh. I think that's already pretty fun. I don't know, we just made a sprite move in a circle without that much code. I think that's pretty exciting, if you ask me. We're going to kick it up just one little notch, nothing too fancy. Just in the context of a game, to make this more kind of valuable to your game, we're just going to make it so that that donut only appears when we collect our power-up. And to do that, under the sprites drawer, we're going to find in the kind of overlaps section on sprite of kind player, overlaps other sprite of kind player. That's the building block we're going to use. Of course, when our sprite, which is a kind player, overlaps the other sprite of kind power-up, is what we really want. That's the combination we want because our orb is a power-up. So To do that, we are just going to pop our set donut to sprite of kind food into that overlap. And then we'll only have an orbiting donut once we collect our power up. As a kind of spoiler, I'm expecting this to not work, and we'll go over why this is not exactly going to work as is. So we move our set donut into the overlap, and then our game should break on us. There we go. Program error, sim error, failed to cast on null. And so what that means is we have our set donut sprite to only be created when we overlap the power up, but in our game update code, we are already addressing the donut, which doesn't exist yet because we haven't collected the power up yet. There are a lot of ways to solve this. My favorite way to solve this is by using a sprite list. And so I'll show you what that's all about right now. So under the loops drawer, we can loop over an element, loop over an element of a list. And so we can pop that in here. I'm going to put this angle changing outside. And so for each element value of list, do this. Now, what is fancy about that is we can set our list to contain all of the objects that are of kind food. So in your game, there may be multiple different kinds of food orbiting around all different kinds of things, and we want to update their position manually. And we can do that by going over the list of those objects. So under the advanced little tab here, under arrays, we can just quickly make a sprite list of all sprites that are of a particular kind. And so we set that sprite list here. And then we want to rename this list to be our, let's say food list. So we set food list to an array of all sprites of kind food, naturally. And then here we can say for element value of the food list from the dropdown. And so, you may have noticed ever since this list was created, it kind of didn't matter that the donut already existed. And then the food list will make sure that when we need the food, it is there and can be acted on. And so there's two things left to change. Well, I guess 2.5. The two kind of halves are, or 1.5s are, we don't really want to call the donut by name here anymore. There could be, I don't know, 100 different kinds of food in our scene that we're all updating its position, and they will all have their own unique names. But because all of our food will be in the food list, we just want to iterate over the value of the food list. So this red bubble here labeled value, if we drop that into the donut, it just takes the place of the donut and acts as a boilerplate, or sorry, as a placeholder variable for all the values in the food list. And so now all we need to do is when we collect the food, we're just going to update the food list. So I'm going to duplicate this. And so we do this here to create the list so that the loop doesn't get angry at us. And then we put set food list to array of sprites of kind food here just to update the list with our newly generated donut. Of course, we don't want too many donuts to be generated all at once. So in this overlap here under the sprites drawer, we are going to destroy the other sprite. The other sprite bubble here is a placeholder for the power up, because again, this makes our code very portable, because we may in our game come across 10 different power-ups, 100 different power-ups. Hard to say how many different power-ups we're going to make. And every time we run this block, we just don't want to destroy that one power orb. We want to get rid of any of the sprites that match that kind, because we need that power-up to disappear so that it doesn't just generate again 100 donuts all at once. And so we set confetti to be our effect for fun, make that a little shorter. So now, without too much further ado, we have our duck that moves around. We have the power orb up over here. As soon as we collect that power orb, it's going to create a donut and put that donut in our food list. And then finally, that food will rotate around our character based on the contents of our on-game update block. So does it work? Bloop. Yes. Not too shabby. One more time. Bloop. Perfect. And so again, in the context of a space shooter game, maybe that orb is like flying around the screen. You have to collect it, and then you get your space shooter power up. The demonstration included a laser beam blast, so we might as well add that in here. We are going to use our controller drawer and say on A button pressed. And here, this is pretty basic stuff. We are going to use our sprites drawer and look for the projectiles, set projectile to projectile of image from my sprite with a certain velocity. So we pop that in our on A button pressed. I'm going to draw a little laser beam real quick. Pretty good laser beam, if you ask me. And of course, they're coming from our duck. And we only want them to move on the X direction. You don't want them to move on a diagonal. So just VX, let's say 120, or maybe 140. Nice fast laser beam. And of course, that works for our duck. Doesn't work for our donut just yet. What we can do there, again, imagining a world where you collected multiple power-ups and maybe you have multiple rotating donuts. What we're going to do is use our loop again to say for element value of list. And we're going to loop over the food list. And again, we're going to fire a projectile. I'm just going to duplicate this block because it already has my perfect laser beam drawing. I'm going to duplicate this block and say that's going to come from the value. Because the value, again, could be any number of donuts firing at the same time. So our duck shoots these great laser beams. We have a power-up orb, which we are gifted with the magical rotating donut. And then now our donut also fires the laser beam. So yeah, that makes you, a threat to be reckoned with in a space shooter game of your designing. And kind of makes it kind of fun. There are many different applications I'm sure you can imagine for this kind of sprite movement, the sine, cosine, radius multiplied by sine of an angle kind of setup. So, imagine in your space shooter game, the enemies are moving in kind of a sine wave pattern. Your power-ups are kind of spinning around somewhere. Any number of potential ways that you can apply that knowledge, and I hope you sure do. And so that's everything I wanted to share with us today, and I really do hope you share your results with us if you do take this on. If you're looking for a bit of a head start, all the code that you see here is available at github.com/mlupo/idealab_codejams. The file there, arcade moving with math.png, is an image file that when you save it and then kind of click and drag that into the Make Code Arcade editor, it'll load the code and you can kind of experiment with it from that perspective. Anyway, do your best to replicate this project or something like it, and hope to see you on the next video. Thanks so much.